Alright, good everyone. This is Ajaks Tutorials and I welcome you back to Ajaks Tutorials YouTube channel. So in today's video, we're going to be going through physics, equilibrium of forces, moment of a force. Now, before I start this video, I would like you to know some certain things. Now, this equilibrium of forces is actually broken down into two. One, which is moment of a force, and two, which is the triangular law of forces that brings about what? Lami's theorem. I already made a video on triangular law of forces and Lami's theorem. I'll put in the description. So we're going to look at the first part of equilibrium of forces, which is what? Moment of a force. And in today's video, we're going to go through the definition of moment. We'll go through the principles of moment, special angles. This Vx and Vy means the horizontal component and the what? Vertical component. Are you following? We'll go through basic moment problem, moment on a couple, reaction and incline moment problems. See, let me tell you something, class. If you are serious with this video, if you can watch this video from beginning to the end, trust me, there is no question or moment that you will not be able to solve. See, you'll be able to solve every single question you find in JAMB examination. And the good thing is this: I'm going to be solving 20 questions in this video, and these 20 questions will cover every single format JAMB will ask you questions on what? Moment of a force. Now let's start. Very quickly, moment is defined. I want you to be with your book and your pen. Moment is defined as the product of force and perpendicular distance of a line of action about a point. All right, that's just English. Now note this formula in your book. Write down. Moment is equal to force times perpendicular distance. Now class, there is a clear difference between work and moment. This one is force times distance. Are you following? This is force times distance, but this is force multiplied by what? Perpendicular distance. Now, this means perpendicular, and we are going to understand what I mean by perpendicular in this video. So just follow me one by one. Now, having defined moment as force times perpendicular distance, let's look at principles of moment. Now, principles of moment, what does it state? Write down. It states that the sum of clockwise moments about a point P is equal to the sum of anti-clockwise moment about the same point P. Are you following? So, principles of moment state the sum of clockwise moment is equal to the sum of what, class? Anti-clockwise moment. Now, let me tell you something. Under principle of moment, there is another theory. All right? And this theory says that the total force in one direction is equal to the total force in the other direction. Meaning that the sum of upward forces is equal to the sum, let me just dictate. Meaning that the sum of upward forces is equal to the sum of downward forces. We are getting there. Now I've defined moment and we have defined principles of moment. This states clockwise moment equal to anti-clockwise. Now let me tell you something. In this video, I am not going to bother you with having to understand what clockwise mean, what anti-clockwise mean. I have a trick. Just chill. We'll get there. I have a trick. A trick that I knew since I was in SS1. Yes. And there is no question on moment on equilibrium of forces I can't solve because of that trick. And I'll be teaching you in this video. So make sure you watch till the end. Okay? Special angles. Now, knowing special angles will help you a lot in moments. It will help you a lot. Even Lami's theorem, like I said, I'll put the video description. I'll put in the description box. So watch that video too. It's part of equilibrium of forces. So now, special angles you have to write down. Let's just draw like a table: sine, cosine, tan. I think this is enough to know. Now this is enough to know. So let's put this place to be the degrees. Now, what are special angles? Special angles are those angles that your examination can ask you to solve questions on without a calculator. Now, the normal JAMB calculator doesn't have sine 97 degrees, no. So there are some certain angles that you need to know their values, their sign, their cos and their tan when you are giving questions. They are called what? Special angles. Normally, we could have proven them using a triangle, but we don't have any time. Okay? This is not mathematics, this is physics. Now, JAMB will never ask you to prove, so don't worry. You just need to know them. We are going to go through 0 degrees, 90 degrees, 30 degrees, 60 degrees. Okay? 0, 90, 30, 60. Now, I want you to follow me carefully and write down. Follow me and what? Write down. Sorry. Now, sine 0 is 0. Cos 0 is 1. Are you following? Tan 0. Now, note that tan is equal to sine over cos. So, sine theta over cos theta. Are you getting it? So, sine over cos. Now, 0 divided by 1 is what? 0. Are you following? Sine 90 is 1. Cos 90 is 0. Tan 90 is 1 divided by 0. 1 divided by 0 normally is undefined, right? So let's just leave this as what? Undefined. So tan 90 is what? Undefined. Now, sine 30. Sine 30 is what, class? 1 over 2. Cos 30 is root 3 over 2. Tan 30 will come back. Let's finish this. Sine 60 is root 3 over 2. Cos 60 is what? 1 over 2 times 60. Now let's look at tan 30. So what's tan 30? Why I'm teaching you this in case you forget how to get the tan in your exam. Just do this divided by this. 1 over 2 divided by root 3 over 2. Right? Sine over cos. So this is what? 1 over 2 times 2 over what? Root 3. Cancel. So this is what? 1 over root 3. Now 1 over root 3 is tan 30. So now this 1 over root 3, when you rationalize, this will be broken down to root 3 over 3. Don't worry, don't bother yourself, just cram this. So tan 30 is either 1 over root 3 or root 3 over what? 3. Now tan 60, this is root 3 over 2 times 2 over 1. That's divided by 2, right? So cancel. So this is what? Root 3. I hope this makes a lot of sense. Now, the reason for me doing this thing here, I will tell you now. And what I'm telling you is because we'll see a question today that you need to apply that knowledge. Now, why am I doing this thing? If you look properly, you're going to see that sine 30, which is 1 over 2, is equal to cos 60, right? I'm going somewhere. Just follow me. Now, sine 60 is equal to what? Cos 30. From the table, I did not tell you anything. It's from the table brought out, right? Now, note this thing. Note that sine theta is equal to cos 90 minus theta. This is what? A trigonometry identity. Note this thing down. And also, cos theta is equal to what? Sine 90 minus theta. Put this down in your book. We'll use it. When we get there, I'll remind you what I just did now. Okay? So now we are done with what? Special angles. That should be written in your notes. Now, let's go. Basic moment problem. Let's start the video properly. So why does this preamble? That's things you need to know before we start. Okay? Note all the special angle. Know this trig identity. Let's start. Alright? So before then, let me tell you about Ajaks tutorials.
My name is Benita, and I was able to secure 333. My experience in Ajaks tutorials was wonderful. The tutors I met were experienced tutors who drilled us with past question sessions. The follow-up coach always ensured that we were not lacking in every class. And even I got an opportunity to meet scholars who held brainstorming sessions that kept us on our toes. My advice of 2026 UTME students is to enroll in Ajaks tutorials because it's a place to be. My scores skyrocketed from last year's UTME from 226 to 333. So it takes scholars from zero to hero. As Ajaks tutorials, no one here is a dullard.
Alright, so welcome back. Now, let me tell you something. Alright? For you to be able to solve moment questions, there are things you need to know. Number one, you need to know the key things I'm writing here. And number two, you need to know how to interpret. The moment you can interpret, then you just do normal mathematics. So the first thing is knowing some key terminologies, alright? Some key points that when you see a question, the thing is not there. But with the point I'll give you now, which is the trick, you'll be able to what? Solve them and interpret the diagrams. Because this particular topic is not every time you'll be giving diagrams. But I've made this video in a way that I took it step by step, alright? So first of all, the first question I'm going to give you guys now has a diagram so that we can picture what we are solving. The second question, no diagram. From there, we move to moment of a couple. From there, we move to what? Reactions and incline moment problems. Okay? So step by step. Now, what I want you to do is this. If you have an earpod or an earpiece, please use it. Okay? Because I want you to be 100% focused. Now, number one point is this. Number one. Anytime you hear uniform meter rule, just know that a uniform meter rule is graded from a 0 to 100 centimeter mark. 0 to 100. I know my light is disturbing, but just be listening to what I'm saying. 0 to 100 centimeter mark. M-A-R-K. Just know this. So anytime you hear uniform meter rule, just know that uniform meter rule is graded from 0 to what? 100. That means it is 100 centimeters long. Number two, note that you should always take the moment about the pivot. Now, in some questions, this pivot can be called fulcrum. That's liver stuff. Fulcrum. Alright? Now, what is a pivot? Pivot is those pointy things, those pointy edge, like knife edge. It looks like this in the question. This is the pivot. This can also serve as a fulcrum. Do you understand fulcrum now? Effort lever fulcrum, load fulcrum. This is it. Now, that's number two. Number three. This thing I'm telling you is very important too. Number three. Note that the mass of a meter rule or the mass of the rod or anything is at the center of gravity. Is at what, class? The center of gravity. Now, class, what is center of gravity? I'm not going to bore you with too much physics terminologies. Center of gravity is just the center of the meter rule. So center of the rule, that's what center of gravity is. Okay? Actually, there are more to it, but this is what you need to know for this topic. Now, the uniform meter rule is rated from 0 to 100. You should always take moment about the pivot, and the mass of a meter rule is at the center of gravity. That's the center of the meter rule. This means that if you have a uniform meter rule, where would the mass be situated? At 50 centimeter mark. Why is it 50? Because a uniform meter rule is rated from 0 to 100, and I told you that the mass is at what? The center of gravity. The center of gravity. Write this thing down in your book. So it means that the mass of the meter will be at the middle of that meter rule. So if you have a meter rule of 25 centimeters, where would the mass be? 12.5. Just do 25 by 2. I hope this makes sense. I'm taking it gently. Now, the last one you need to now do is number 4. You need to take, after taking moment about the pivot, always look out for the distance. Now, in brackets, perpendicular distance. Are you following? The distance between the loads or forces or masses, any one the question tell you. Always look out for the distance between the loads or forces to the pivot. Now, class, we are done. I'm going to take this very gently again. Number 1, uniform meter rule is rated from 0 to 100. 2, you should always take the moment about the pivot. 3, the mass of the meter rule is at the center of gravity. And for your level, just know that center of gravity means center of the rule, center of the meter rule. Number 4, always look out for the perpendicular distance between the loads or forces to the pivot. And I already told you that this is what a pivot looks like. Now, the distance between that load to the pivot is what we call the perpendicular distance. Now, I'm going to solve a lot of questions now. And you see that we're not doing anything like is the clock going here, is the clock not going here. Those things are confusing. Even for me then, when I was in secondary school, I was not really clicking, understanding what was happening. But when I learned this trick, there is no question I was not able to solve. Question 1. So this is how it's going to go. We are going to leave this here for a while, maybe from question 1 to 4, till we are now mature enough to solve. So make sure you write this in your book, but I'm going to leave it here for now. Now, question 1 will appear on your screen now. This is the diagram for it. It will appear on your screen now. It says, in the diagram below, so in the diagram on the board, AB represents a uniform rod of 1.5 meter. A uniform rod of 1.5 meters in which is in equilibrium on a pivot at P. If AP is 40 centimeters, calculate the mass of the rod. Now, class, first step is to understand the question. The second step is to interpret the question. And the last step is to do your mathematics. The question says, in a diagram below, AB represents a uniform rod of length 1.5. I told you that a uniform meter rule is rated from 0 to 100, but they already told us that it's a uniform rod. And they gave us the length. Is it they don't give you the length and they tell you it's a uniform meter rule, then you know it is 100 centimeters. Don't forget, 100 centimeters is same thing as what? 1 meters. So this question says 1.5 meters. 1.5 meters means 150 centimeters. If you don't understand, just know that 1 meters is equal to 100 centimeters. So multiply 1.5 by 100, you get what? 150 meters. This basically tells us that this meter rule is 150 centimeters long, right? So it means from here to here is 150. So I'll put 150 centimeters here. Now, what other information? They said AB, that's AB, okay, representing the uniform meter rule, which is at equilibrium at a pivot P. Now, this is the pivot. Now, if AP is 40, that is the distance from this 7 Newton force to the pivot is 40 centimeters. Calculate the mass of the what? Pivot. Given that the acceleration due to gravity G is 10. Now, what can we do? The mass of the pivot. Now, look at 3. The mass of a meter rule or a rod or anything is always situated at the center of gravity, which is at the center of the rule. Class, if the rule is 150 centimeters, where do you think the mass will be? The mass will be at, go to your calculator fast. It will be at 150 divided by 2. 75 centimeter mark. That is where it will be. So you put, now let me tell you something. When you are doing this, when you are trying to draw a diagram or interpret the question, you have to be realistic. From year to year is 40. And this whole thing, 150. This whole thing is not 150. From year to year is 150 minus 40, which is 110, right? So if you want to put 75, you cannot put 75 here. You're not being realistic. So what you just do is try to be realistic. I don't mean in your exam you should not start drawing and be finding 75. No, but just be realistic. It doesn't matter anyway, but it gives you a good picture of how your question is. So let's say 75 is somewhere here. Now it means that this is where the mass will be. This is where the mass will be. Are you following? But now remember that this is in Newton. So mass is in kilogram and all your options are in kilogram, right? Your options are in kilogram. Check. So mass is in Newton, mass is in kilogram. So what we just basically do is, let's make this part weight. They won't find the weight, we divide by 10 to get the mass. Or you know, worry, don't bother yourself. What we'll do is, we'll just say 10m. No, let me not confuse you guys. Let's leave it as mass. All right, let's leave it as mass. But all you need to know is that this is 7 Newton, and Newton is a weight. So weight, W equal mg. Do you understand? So the weight here, this is meant to be a weight. So let's just put 10m. As acceleration due to gravity, mass is 10. Mass is what we don't know, right? G is 10, so that's 10m. I hope this makes sense. Now let's start. Let's solve. What I say you should do, always take moment about the pivot. So it means that we are taking moment about this pivot. Moment about pivot P. Now moment about pivot P. How can we do this? I said always look for the distance between the loads or forces to the pivot. Now what you do is left equal right equal left, or left equal right. That's all. Don't say clockwise moment, anti-clockwise. Don't stress. Left equal right. Left equal right. The forces multiplied by the distance to the pivot equal to the other side, the forces multiplied by distance to the pivot. So now how many forces do we have here? We have 7 Newton and we have what? 10m. All right, good. So let's start with this part. 7. So I'm taking moment about the pivot now. 7 multiplied by, what's the distance from year to year? 40, right? Equal to 10m, which is the force, multiplied by the distance. Let me use multiplication sign. Multiplied by the distance. Now, what's distance from year to year? Class, listen. This place, this thing now is 40. So it means this is 40 centimeters mark. So if this is 40 centimeter mark, it means from year to year is 75 minus 40. Do you understand? So let me just take this back to my bracket. 75 minus 40. I hope this makes sense. 70, 10, right? So this is 7 times 4 equal to m multiplied by 75 minus 40 class is what? 35. So what will my m be, class? My m will be 28. That's 7 times 4 divided by what? 35. So 28 divided by 35, go to your calculator. 28 divided by 35 is 0.8. 0.8 what? Kilogram. Now, if you decide to leave this as weight, you get 8 Newton. So you cannot say W equal mg. 8 divided by 10, 0.8. So anyone is fine. So I hope we understand now this question 1. Now let's move to question 2. You see the question on your screen now. A uniform meter rule AB is balanced on a knife edge. I'll read it first, then I'll interpret. Is balanced on a knife edge which is 55 centimeters from B. If a mass of 10 gram is hung at P, which is 10 centimeters from A, calculate the mass of the meter rule. Now let's solve. Let's interpret. First, a uniform meter rule. So it means that this uniform meter rule, it is from 0 to what? 100. You can see why all these things are important. Now, let's draw a meter rule. 0 to what? 100 centimeter. Now, what next? Is balanced on a knife edge. That means you put this meter rule on a knife edge like this. Now, which is 55 centimeters from B. So this meter rule is AB. I'll use my red marker for the distance, okay? So which is 55 centimeters from B. So if something is 55 centimeters from B, it means that, let me say, first of all, where is the middle of this thing? This thing I drew now. Let me say the middle is somewhere here. Let me say the middle is somewhere here. Right? Now, it is 55 centimeters from B. It means from here to here is 50. This is the middle. So it means from here to here is 50. Right? Here to here is 50. That means if I want to put 55, it will be more than this place. I've been now, but 55 centimeters from B. Did not say from A. So it means from here to here, which is 50. If I push this thing forward, then this is where my pivot is. Or my knife edge. So it means that, listen, it means that from here to here is 55 centimeter. This doesn't mean that this is 55 centimeters mark. No. If you do your mathematics properly, this particular from here to here, from here to here is 45. But the mark that is here is 45 centimeters mark. Don't get confused. Calm down. Don't get confused. Let me explain again. The question says the pivot or the knife edge was 55 centimeters from B. Now, if this is 55 centimeters from B, it means as you're coming like this, when you cross 50, which is the middle of the meter rule, what you will reach now, you need extra 5 to make the distance 55 from there. But looking at it from this side, it is actually 45 centimeters from A. And since the meter rule is starting from 0 in this place to this place, it makes sense that this is 45. This is 50. Somewhere here is 55. So don't make mistake and say it is from here to here to B. No. You have misinterpreted the question. Okay? Now, let's continue. So it's 55 centimeters from B. If a mass of 10 grams is hung at P, which is 10 centimeters from A. Good. Now, class, 10 centimeters from A. P is 10 centimeters from A. So 10 centimeters from A will be somewhere here, right? So this is my point P. And what mass was hung at this point? 10 gram mass. Are you following? So 10 centimeters. So it means that from here to here is 10 centimeters. Just draw in your book. Are you getting it now? Calculate the mass of the meter rule. So the mass of the meter rule, where do you think the mass of the meter rule will be? It will be at the center of the rule. Now the rule is from 0 to 100. So class, what's the center of this meter rule? The center of this meter rule is at this point here that you understand? And let me reduce my pivots. So the center of the meter rule is here. And that's where the mass of the meter will be, M. Now that we already have this in gram, we don't have to multiply this by 10. I hope this makes sense. Now, we solve. What should you do? Take moment about the pivot. In this case, it is about the knife edge. That's the knife edge. So taking moment about the knife edge. About the knife edge. So you do, see, let me tell you something here. Let me tell you something. Just, there must always be forces by the left and by the right. So just look at the fulcrum, the pivot should be your main focus. Look what is happening on the left side? How many forces are here? How many forces are here? This is the pivot. What's the left side? Only this one. 10. Multiplied by what is the distance? Always look for the distance between the loads to the pivot. What's the distance from this 10 to the pivot? Class, remember, that's why you need to be drawing your diagrams neatly so that you can see what you're solving. Now, remember, I'm sure this is working. Okay. Now, remember that the distance from here to here is 10. And the fulcrum or the knife edge was at the 45 centimeter mark. So to find the distance from this 10 to the pivot is what? 45 minus 10, which is what? 35 centimeter. Equal to, now, this mass multiplied by what? The distance, the mass was at the 50 centimeter mark. So this is my 50 centimeter mark. Class, what's the distance from 50 to the pivot or the knife edge? What? 5. 50 minus 45. I hope this makes sense. Okay? So what my mass be finally? 5 here, 1. 5 here, 7. My mass will be what? 70 grams. Option A. Correct. So I hope this makes sense. You can see, very, very simple question. No need to stress. You just need to know how to interpret. That's all. Let's look at question 3. If you have any questions, please ask in the comment box. Okay? So quickly, let's look at question 3. Let's look at question 3. It's very, very simple too. So question 3 says a uniform meter rule QR. So QR. Okay? This from the diagram. You know, some will give you diagrams, some won't. So uniform meter rule QR, which is 55 from R. So QR, and it is uniform. So it means that this is my 0 mark, and this is my 100 centimeter mark. 100 centimeter. Are you following? It says which is 10 gram is hung at P as shown below. What is the mass of the meter rule? So it is similar to what we just finished doing, Abby. I don't even know why I even had this one, but let's solve anyways. So what's the mass of the meter rule? Now we're looking for the mass of the meter rule. Where is the mass of the meter rule? At the center, right? So at the center, M. Okay? What else? So there's a knife edge that was 55 from R. So we already did this before. This is 50. This part is 50 centimeters. Why? Because it is the center of the meter rule. So it is 55 centimeters from R. It means 55 is somewhere here. If you're looking from here, 55 is here. But if you're looking from here, 55 centimeter mark is here. But they say from R. So it's from there we'll look at. So put 55 somewhere here. So this is my knife edge. And this is 45. But 55 to this place. Do you understand? So let's just find the mass. It's very, very simple. 10 multiplied by distance. If this is 10, from here to here will be 45 minus 10, which is 35. Equal to, this is M, and this place is at 50, and this is at 45. So it means what? 50 minus 45, right? 5. So this is same thing now. M is what? 70 grams. Okay? Question 4. Now let's solve question 4 here. Question 4 says masses M1 and M2 at the 20 centimeters and 65 centimeters mark respectively of a uniform meter rule freely suspended at its center of gravity. If the meter rule balances horizontally, determine the ratio of M2 to M1. This is a very critical question. You have to open your ears. I go again. Masses M1 and M2 at 20 and 65 centimeters mark respectively of a uniform meter rule freely suspended, we'll come there first, hold on, of a uniform meter rule. This is 0, this is 100. So masses M1 and M2. So M1 is at 20, M2 is at 65. So let's first find the mass, then we'll be able to smartly place the distances. So let's the mass somewhere here, that's this place at 50, right? Now M1 and M2 were at 20 and 65 respectively. So yes, let's say here is 20. So this is my M1, my first mass at what? 20, and M2 at 65. 65 will be more than this now, abi? So 65 somewhere here. M2. Do you understand? So this is 65. Freely suspended at its center of gravity. This is very key. Now, if something is freely suspended, the question further said, if the meter rule balances horizontally. Now, freely suspending means there was a pivot, but they don't tell you. Now, there was a pivot that was placed in the meter rule. Hey, my phone go follow. Go follow. Wait. Hey, don't worry. Me, I don't try my luck. So, it's freely suspended this guy. Aha. That is. My phone break. Now what this phone is. So, it was freely suspended. So, it means this point is the pivot. It was suspended at the center of gravity. Center of gravity. So this is my pivot. Then he now made this guy balance. Now, what's the ratio of M2 to M1? This question is very sweet. What's the ratio of M2 to M1? M2 to M1. M2 to M1. Let's solve. Next question will clean all this guy so we'll have more space. Now, M2 to M1. Let's solve normally. First, let's find the distances between each of the masses to the pivots. Now, from here to here is 20, here is 50. So it means from here to here is 30. 50 minus 20. So here to here is 30. This one we call 65 minus 50. So here to here is what? 65 minus 50 is what? 15. Are you getting it now? We can solve normally. Let's take moment about this pivot. M1 multiplied by 30 equal to M2 multiplied by what? 15. Now, class. 1, 2, right? It means 2 of M1 is equal to M2. Bring it here. 2M1 is equal to M2. The question says, what's the ratio of M2 to M1? So, we are looking for M2 over M1. This is our goal. Right? So, what's the ratio of M2 to M1? Divide both sides by M1. M1 cancel M1. So, it means my M2 to M1 is equal to what? 2 over 1. That's what? 2 ratio 1. Option A. Now, can you guys see how this was interpreted? They say it was freely suspended. It was freely suspended. You are freely suspended. They did not tell you that was pivot. That's why you need to practice more questions. And that's why you need to watch this video to the end. These are the kind of things I'm saying. Okay? Let's look at question 5.
As when Samuel Chukwemeka, I scored 372 in the recently completed UTME 2025. I was the top Ajaks tutorials of all students Ajakites that competed for this team. My special appreciation goes to God and the Ajaks tutorials team for making this a success and making this real, like a reality. And it now come on the platter of gold. It came with a series of sacrifices, hard work, diligence, and faith to God. I think the bi-monthly mock really helped a lot. It was really helpful because I participated in the mock and it gave us an insight on what UTME might look like or will look like eventually. We were able to compete with several Ajakites and we were able to show our skills and show our potentials. I joined 2026 JAMBITES and beyond to join these tutorials. We want to blast jump forever.
Alright, so welcome back. Now we have more space. Question 5. Now, question 5 says, You see it on your screen now. A uniform meter rule weighing 0.5 Newton. Now, listen. If they say the uniform meter rule is weighing 0.5, it means that is where the weight of the, that means it means the weight of the meter rule, which is 0.5, is at the middle. Because that's the weight of the meter rule. Do you understand? So uniform meter rule weighing 0.5 Newton is pivoted on a knife edge at the 30 centimeter mark. So as we are reading, let's be drawing. A uniform meter rule, sorry, excuse me. A uniform meter rule, 0 to 100. 0 to 100, it is weighing 0.5 Newton. Happy now? So this is 0.5 Newton. Please, I always like confirming my mic is on so I don't just be teaching. Please, hold on. Okay, so weighing 0.5 Newton is pivoted on a knife edge at the 30 centimeters mark. So if it is 0 to 100 and it is weighing 0.5, it means that this was the 50 centimeter because it's the middle, center of gravity. And they said it was pivoted at 30, so it will be somewhere here, right? Pivot at 30. 30. Where will a force where will a force of 2 Newton be placed? No, I laughed because I've seen this question before and it's crazy. Just listen. Where will a force of 2 Newton be placed from the pivot to balance the meter rule? Put your ears. Where will a force, where will it be placed? 2 Newton force, where will it be placed to balance the meter rule? Now, listen to me attentively. Listen to me attentively. If you want to balance this meter rule, where do you think you place this force? Let's start that. Let's start with that, like logically. Where do you think you place this force? Because many of you might not know. Trust me, I'm not trying to say you don't know anything. I understand. You might not really understand the concept of moment. But let me explain now. Where will you place this force? Now listen. This is a meter rule. Alright? There is a pivot here. And there is a force here. To balance this my phone, if a pivot is here and a force is here, where do you think I will place another force to make my phone balanced? I'll place it here. Do you understand? If you place this thing here, this meter rule, see, look at my hand. If you place this thing here, this meter rule will fall. But if you place it here at a nice point, it will be balanced. So it must be here. That's one trick you need to know now. Okay? Now, let's place, we don't know, but we'll just put it somewhere. Force of what? 2 Newton, right? 2 Newton. Now, we're not done. No. You solve. You solve. Now, do you know this point? No, you don't. You don't know. So, you put X. Now, this is where it gets tricky. Open your ears. Class, is X smaller than 30 or not? It is now. Because from here is 0. So, at this point, it will be definitely less than 30. Now, let's solve. Taking moment about this pivot, I'm going to write again. JAMB, you're a JAMB student or a YX student, okay? But if you're a YX, then write it down. So taking moment about this pivot, 2 multiplied by, okay, let me write it here. 2 multiplied by the distance, the perpendicular distance from here to here. Now, will you say x minus 30? No, now. Why is no x minus 30? Because 30 is more than x. So imagine here was 10. What will you say? 30 minus 10. So that's it. 30 minus x. Equal to this point from here to here. Perpendicular distance. So 0.5 multiplied by what? So from here to here, if here is 30 and here is 50, it means from here to here is 20. Do you understand? Do you get? So 2 here 1, 2 here, 10. And 0.5 times 10 is 5. I be now press your calculator. So 30 minus x equal to what? 5. Are you getting what I'm trying to say? This is what? 5. Now, what are we going to do? Take this to this side. Bring this here. This is what? X equal to what? 25 centimeter. Now, it means that this point was at 0.25 centimeters mark. Now, we have gotten x as 25. Option B is correct. I hope this makes a lot of sense. Okay, good. All right, now we are going to move a bit advanced. Okay, now normally if you notice, all we have been doing is one force here, another force here. Now let's see a question that involves more than one forces between like from this side of the pivot to the other side of the pivot. More than one forces. Okay, now question 6. The question up here on your screen now is on the board. A uniform light rod is kept in horizontal equilibrium under the influence of 4 forces, 1, 2, 3, 4. Which of the equations correctly represents the condition for equilibrium of the rod? Class, for equilibrium to be said to occur here, it means that the moment about this pivot, all right, from all the forces must be equal. What do I mean? Let's start with moments about, let's call this pivot P, and let's take moment about this pivot. Now, force times the distance, force times the perpendicular distance, that is the force multiplied by the distance from here to the pivot. We'll do it one by one. Let's start with F1. F1, open bracket. What's distance from F1 to the pivot? Is A. See, from here to here is A. Equal to, no, you're not doing equal to. Why is not equal to? Because there is another force here. So it's not going to be equal to, it's going to be what? Plus F2 multiplied by B equal to F3 multiplied by C plus FD multiplied by, F4. F4 multiplied by what? D. Do you understand? So this is what? F1A plus F2B equal to F3C plus F4D. Now, why I brought about this question is because when you are having more than 2 forces here or more than 1 forces here, you don't need to say equal to, just add them. Okay? So this multiplied by perpendicular distance first plus the moment here. So it's just basically saying the moment here plus the moment here must be equal to the moment here plus the moment here for equilibrium to occur. So from this particular one, if you look at all the options, nothing is really clicking. But let's put our eyes on option D. Now, if I'm bringing this guy here, I'll have F1A plus F2B minus F3C minus F4D. What we left here, nothing, equals 0. Option D is correct. I hope this makes a lot of sense. So option D is what is correct. So that's basically how to solve questions when you have more than 1 forces. Now let's see an actual question. Question 7. Question 7 says, you see on your screen now, the figure below shows a seesaw. I don't want to draw it because it wastes my time. I'll put the figure on the board now. The figure below shows a seesaw, which is, seesaw now, that's in your kindergarten, in primary school. A seesaw which is exactly balanced. So the seesaw is balanced. The weights of the people sitting on it are 50 kilogram, X kilogram, 15 kilogram as shown. They sit at distances of 1.5 meters, 1.5 meters, and 2 meters from the pivot respectively. What is the value of X? So let's quickly look at these pivots. I'm not drawing them, I can't draw. So let's just, our business is basically their masses and the distance. Okay, so let's put this, there's a pivot here, and there is one guy here that is, one guy that his weight is 50. Always put weight down. Weight is a downward force. All right, weight is a downward force. So always make sure it's down. It's a reaction that is up will do it. So don't make mistake and say no. It's meant to be down. So there's this guy here, and distance to the pivot is 1.5 meters. Then what else? There's another guy here, X. We don't know the weight, so put X kilogram. Do you understand? And distance to the pivot is also 1.5 meters. Just put something like this. And there's another guy here, which is 2 meters, but this is not really realistic. Let's put somewhere here, something like this. So another guy is 2 kilogram. Oh, sorry, 15 kilogram. And it is 2 meters away from the pivot. So it means from here, everything is 2 meters. Now, what is X? Simple. Simple. Like mad. Let me make this thing bigger so we can see what I'm doing. This is 15 kilogram. Now, let's solve. 50 multiplied by, so this is pivot. We're taking a moment about the pivot. So 50 multiplied by the perpendicular distance. So what's the distance from this 50 to the pivot? 1.5. Equal to, now listen, pay attention. You can take anyone. There is no order in this thing. Take anyone. But I always prefer you take the first year. Okay? So let's take this one. 15 multiplied by, what's the distance from 15 to the pivot? 2. Right? Hope I'm not making any mistake. 2, good. Plus X, that's this force. Multiplied by 1.5. You know I did plus now because they are on the same side. If this one was here, this will be this plus this equal to this. You get a So let's solve. 50 multiplied by 1.5. Okay, so let's just quickly use calculator to not waste our time. 50 multiplied by 1.5 is what? 75 equal to 30 plus now 1.5x. So take this one here, 75 minus 30 equal to 1.5x. So 1.5x will now be equal to what? 45. Take this one here. What my x be class? 45 divided by what? 15. That's 3. 3 what? Kilogram. So that's option what? It's question 7. Okay, so 3 kilogram option. This is in 3. Hold on. No. 45. Sorry, 30. Very 1.5. I said 15. 1.5. 30. So option B is correct. I hope this makes a lot of sense. Okay? Good. Now, question 8. Question 8. You see it on your screen now. So this is my question 7, and I'll do question 8 now. So question 8 says, in the figure below, PT is a uniform meter rule pivoted at arrow. Now, you know what? Let's draw this guy. Question 8. So the diagram is very, very simple. Like this. This is the it gave us from the question. So this is my P and this is my T. Then here, like this, is my arrow. Then there is something here that is 0.4 Newton, and that's my S. Then there is something here which is Q coming down 0.1 Newton. Okay, so it says that PT is a uniform meter rule. It means from here to here is 100. Let me get another marker so I used to draw the distance. Okay, so PT is 100. So it means that this is 0 and this is 100. Right? Okay. The 70 centimeter. Okay, so the PT is a uniform meter rule pivoted at R. So it's pivoted at R at 70 centimeters mark. So it means that this is 70. The pivot. Do you understand? Two forces 0.1 Newton and 0.4 Newton are applied at Q. 0.1 at Q, 0.1 at Q, and 0.4 at S are applied at Q, the 60 centimeters mark. So at this point is 60. Right? And S, the 85 centimeter mark. So at this point is 85. If the meter is kept in equilibrium by the forces and its weight, calculate the weight of the meter rule. So what's the weight of the meter rule? That's the mass of the meter, right? It will be at the what? Center. You can see how this thing I'm teaching you is coming to pass now here. So it will be at the center. So let's put 50. So if here to here is 60, it means somewhere here will be 50. So let's just put something down that indicates the weight of the meter rule. Let me do it like this. So it doesn't obstruct this my 0.1. Okay, let me put somewhere here. So this is my weight. And that's what I'm looking for. And is that what? 50. I hope this makes sense. Now, what's left for us is to solve. That's all. That's all. Now, taking moment about the pivot. That's taking moment about this pivot. Taking moment about that pivot. Let's start with this guy. W multiplied by what's the distance from here to the pivot. The pivot is at 70. But W is the weight, which is at center of gravity at 50. Alright? I know this is not really looking like, it's not looking realistic, but let's leave it like that. Okay? So 70 minus 50 is what? 20. Let me put it like that so you guys are not getting confused. Is it equal to yes? No. Plus. Why is it plus Ajaks? Because we're not done. There is still 0.1 force here. So plus 0.1. Hold on. I always try to make my solvings very, very clear. So W multiplied by 70 minus 50 plus 0.1 multiplied by, now what's the distance from this 0.1 force to this? This is 70 and these are 60. That's 10. Equal to this plot, this force here. So 0.4 is at 85 and the pivot is at 70. So 85 minus 70. So 0.4. 85 minus 70 is what? 15. There was no space even I would have written that. Okay? So let's just do this guy. This is 10. No, sorry, 20. 20 W plus this 10 now. 0.1 times 10 equal to 0.4 times 15. 0.4, I'm using your normal calculator, JAMB calculator, times 15. That's 6. So 0.1 times 10 is 1. Now, so 20W will equal to 6 minus 1. You know now, taking this guy to the other side. I hope this makes sense. So 20W is equal to 5. So what's my W class? 5 over 20. That's what class? 1 over 4. 0.25 Newton. So according to our option, 0.25 Newton is the answer. That's the weight of the meter rule. Option A. I hope this makes a lot of sense. So if you are enjoying this video, please do well to like and subscribe to this channel. Okay? All right, now welcome back. Now let's look at question 9. Two masses, 40 gram and 60 gram respectively, are attached firmly to the ends of a light meter rule. The center of gravity is, okay, the center of gravity of the system is okay, now let's solve. Two masses, 40 gram and 60 gram respectively, are attached to the ends of a light meter rule. Listen attentively. A meter rule. One end, another end, right? Right? So there is one mass at one end, which is 40 gram, and there is another mass at the other end, which is 60 grams. Now, what the question says, it says they are attached firmly at the ends of a meter rule. The center of gravity of the system is, so we are looking for the center of gravity of the system. How can we do this now? What the question is basically asking us to find is the mass of the meter rule. All right, the mass of the meter rule, where will it be? That's what's going to be the distance from the center of gravity of this system to each of the forces. Let's solve it normally. Now, normally we know that it's going to be at the center, right? We know it's going to be at the center, the mass. So put this place as the mass, but we don't have any business. So we don't have any business with this guy. I'll tell you why. So they said it is a light meter rule. So 0, 100. Are you following? Now, listen attentively. Listen. If we don't know where the center of gravity will be, normally we know it's at the center. But the question is asking us what is going to be the distance between these masses. It is impossible. Listen attentively. Listen attentively. I know you guys may be getting confused, but listen. It is not possible for this thing to be at 50. Why? Because if it's at 50, then these masses are not correct. It's only going to be at 50. That means this is 40 and this is 60. And if they were the same masses, then they will have the same distance between each other. But they're not the same masses. So I cannot put this at 50. So we're looking for what will this mass, where will this mass be? Normally, we put it at the center, right? We put it at the center. But in this particular question, we can't put it at the center. Because if we put it at the center, it means that it is 50 from here and 50 from here, which doesn't make any sense. Why does it not make sense? Because they are of different masses. It's only when this was 50 and this is 50, or this was 40 and this is 40, that is when they should be in the same distance to the pivot. I hope this makes sense. Now let's solve. The center of gravity of the system is, so let's assume we don't know where this thing is. Now, if we don't know where this thing is, we can basically say from here to this place, we can put it as it is x. And we can say from here to this place, we can put that is what? 100 minus x. I hope this makes sense. 100 minus x, because now let's find x. We don't have business with this guy. Assume this is a pivot. Alright, because that's the system we are taking moment to. We're taking moment about the system. So 40 multiplied by x, that's distance, perpendicular distance from 40 to the pivot, equal to 60 multiplied by 100 minus x. I hope this makes sense. Good. So what is it going to be, class? What is it going to be? 40x is equal to 60. Let's do like this. I don't want to have big numbers. Right? 4x will be equal to what? 6 open bracket 100 minus x. So let's break this. 4x will be equal to 600 minus 6x. Bring this guy here. If I'm bringing this guy here, it's going to be 4x plus 6x equal to 600. This is what? 10x equal to what? 600. So x will be what? 60. Now, centimeters. Now, listen attentively. Listen, don't be rushed to conclude. If here is 60, it means here will be what? 40. Abi? Now, A, at the midpoint of the meter rule, which many of you will pick, but it's wrong because they're not the same distance. They're not the same mass. The reason why we're doing all those ones before is because if you remember, we're always either finding the mass or we're finding the distance. That's why we're placing it at the middle. Do you understand? But this now, we have just two forces here. We can't say that. Okay, let me explain something to you. If this was a long ruler, and you use a baby hand putting it down here, no, it's baby hand, and you bring a small stone, put it in one side, and you bring a large stone, put it in the other side, the large stone, the ruler will fall like this because the last one is here. Now, if you put that ruler at some distance away from the pivot, it will balance with the small stone. But you cannot put that ruler on at the same distance with the small stone. Like if the small stone is at 50, the big stone will not be at 50 because it will not be balanced. Do you get it now? So if you're having different forces, don't assume it's at the center. So option A is wrong. B, 40 centimeter from the lighter mass. The lighter mass is 40 gram. So it's not 40 centimeter, it is 60 centimeter from the lighter mass. So option B is wrong. Option D, 60 centimeter from the heavier mass. The heavier mass is 60 gram, but it is 40 centimeter away. So the only option is what? Option C. It is 40 centimeter from the heavier mass. You can see how this question was dismantled, okay? I hope this makes a lot of sense. Now, question 10. Alright, so question 10 says, it will appear on your screen now, a uniform meter rule of weight 40 Newton has a piece of metal of 20 Newton attached to one of its end. The center of gravity of the system from the weighted end is, now listen, a uniform meter rule of weight 40 Newton. Now, if you recall, I told you that the mass of a meter rule is usually at the center of gravity. But I want to rephrase so that you don't get confused. You know, if you remember, I told you that there is more to center of gravity. But for your level, just know that center of gravity is the word center. Now, I want you to rephrase that and note that the mass of a meter rule, all right, is at the center of that meter rule. Okay, let's leave center of gravity alone because this question and this one is basically telling you that there is more to center of gravity. Now, a uniform meter rule 0 to 100 of weight 40 Newton at the center, 40 Newton. So 50 centimeter now, be good. It's attached to one, so the 20 Newton is attached to one of its end. So we can use any end. We can use this end, we can use this end. So let's use this end. Okay, let's use this end. In fact, in your own, try and use this end and tell me whether I got the same answer in the comment section. Okay, try it. So this end, 20 Newton. The center of gravity of the system from the weighted end is, now that center of gravity in questions like this is basically where is the point that the uniform rod or the uniform meter will be balanced. That's what center of gravity means in this context of questions like this. So if you have a force here and you have a force here, where do you think you put the pivot for it to be balanced? Here, in between. It can't be here, because if it is here, the meter will fall down like this. So put somewhere here. We don't know the point, but that's what we're looking for now. So you put your own 20 newtons here, your pivot will be in between. So try it and put in the comment section if you got the same answer. Okay, now let's solve normally. So we already know from here to here is 50. It means if here to here is x, so if here to here is x, it means that here to here is what? 50 minus x. Just like how we did here now, abi? So let's solve it here. 20 multiplied by x, 20x equal to 40 multiplied by 50 minus x. Right? 20x equal to, this is okay, let's do the same thing we did before. 0 cancel 0, 2 here 1, 2 here 2, right? So x will be equal to what? 2 open bracket 50 minus x. This seems a bit more simpler to solve, right? So x will now be equal to 100 minus 2x. I hope we are getting it. Take this one to this other side. This is going to be x plus 2x equal to 100. Where can we solve this now? Let me create a space here. So this is what? 3x equal to what? 100. What my x be, class? My x be what? 100 over 3. Which is what, class? 33.33. Option D. I hope this makes a lot of sense. So that's basically how you can solve questions like this, okay? Now let's look at question 11. Question 11 says, okay, this one is, I need to clean the board first, okay? Alright, so question 11 says, a uniform rod of length 1 meters. So a uniform rod of length 1 meters. So let's always use 100. So 1 meters means 100. Alright, of length 1 meters and mass 2 kilograms. So the mass is at the center now. By now we should have known all these things. So mass 2 kilogram and the mass is at 50 centimeter mark. Is pivoted at the end of P. So a uniform meter rod PQ. So it's pivoted at the end of P. Yes, so it's pivoted here. Are you following? If a load of 14 Newton is placed at the center of the rod, class, there is already a mass of the meter rule, but they told you that there is another load that was placed on this mass. Now, 14 Newton is placed here. We can't add, it's impossible to add 14 Newton plus 2 kilogram. So what we can do, we'll change this guy to Newton by saying mg. That's 2 times 10. That's 20. Are you following? So we'll now bring this down again. 14. So 14 plus 20 is what, class? 34. I hope this makes sense. So 34 is the entire mass that will now be here. Newton. Alright, if you don't understand, calm down. There was 2 here before. They said that a load of 14 was added to it. So it's just more like saying that 2 kilogram plus 70 plus 14 Newton. 2 kilogram and 14 Newton, they have different units. So you must change the kilogram to Newton first before you can successfully add it to 14. So kilogram to Newton, W equal mg. 2 times 10 is 20. 20 plus 14 is 34. So 34 Newton. Is placed at the end of the rod. Find the force that should be applied vertically upwards to Q to maintain the rod in equilibrium horizontally. So we are looking for a force that must be applied vertically upward at Q. A force upward at Q. Now, if you remember when I was giving you guys the principles of movement, I told you that the second theorem says that the sum of forces in one direction is equal to the sum of forces in the other direction. Now, this basically means that the moment about this pivot, so if we are taking moment about the pivot, what is happening is that we are saying F multiplied by the total distance, the perpendicular distance moved by F to the pivot. So from here to here is 100. Do you understand? They said what will be the vertical force at Q. So it is at the other end that the vertical force is up. 100 equal to, so now, you know I told you that if they are in the same side you add, but they are in the same side. Yes, I know they are in the same side, but they are not in the same direction. This one is coming down, this one is coming up. So it is the same way you are going to treat it if it's in different direction. So if this guy now was down, we will now say 34 times 50 plus F times this. But now it is up. Do you get? This is actually meant to be in this part. Okay? So this multiplied by this equal to 34 multiplied by what? 50. 0 cancel 0. 5 here 1. 5 here 2. 2F equal to what? 34. So my F will be equal to what? 34 divided by 2, which is what? 17 Newton. Option C is correct. So how this makes a lot of sense. So that's basically it. That's basically how to solve questions like this. Okay? Don't forget, this one that is up, you take it down. Alright? This one, you multiply. So you equate because they have different directions. Okay? Question 12. You see it on your screen now. So that's the last question we'll solve on this aspect. Then we'll look at moment of a couple and reaction and reactions and incline moment problems. This one is very, very important. So just this one is very simple. Moment of a couple. It's simple. We won't solve any JAMB question on that because it's very simple. Okay? This one will focus on more. So number 12, the diagram below, you see the diagram on your screen now. The diagram below shows a plank RS pivoted at the center of gravity O and is in equilibrium with the weight P and Q. If a weight 2P is added to P, the plank will be in equilibrium again by, now let me explain this question. Listen attentively. So you have a plank R S O and there's a P and there's a Q. Now, normally, the question told you that it is balanced. That means it's in equilibrium, right? Then I told you that in this P, another 2P was added here. Yes, they added more 2P to this guy. Now, how can you now make this guy in equilibrium again? Now, if they're in equilibrium, it basically means that we are assuming they are of the same masses, of equal masses. And if they are of equal masses, they are going to be of equal distance. Are you getting it? They're going to be of equal what? Distance. Do you understand? If they have the same masses, they'll be of equal distance. Now, if this one is now increased, you now increase the mass to 2. You now added 2p. So if you add 2p to this guy, it's giving you 3p. It means that it is impossible for this to be in equilibrium except something happens. That means if this thing is 3p and this is q, but like I said, they have the same mass. Let me say pp. Now let's say yes p, and I now add 2p to this one. This now becomes 3p and yes p. It is not possible for them to be in the same distance to the pivot. It's not possible because it doesn't make any sense. Just like what I told you, you have a big stone here, you have a small stone here. They cannot be of the same distance to the pivot. What will you do? Now, the question says A, moving Q nearer to O. No. B, okay, C, adding a weight Q to Q. No. If you add one Q here, this still overrides this. And D, pushing P further away from O. Now, if you push this guy away, what you are basically doing is this. This whole system will fall like this. Do you get? Now, let me explain why. Note this thing. When there is an increase in mass, in moments, there should be a decrease in the distance. That means when the mass is increased on one end, all right, the particular mass should move further to the fulcrum or pivot for equilibrium to what take place. If you solve all your moment question properly, you will see that the larger mass has more lesser distance than the bigger force. The larger mass has more smaller distance than the smaller mass. Look at this question. What was this mass? 17. What was this one? 34. You can see there's a smaller distance here. Check all our questions that I've been solving. Check it now. You see that the smaller the distance to the fulcrum, the bigger the mass. So, to make equilibrium balanced here, you're having a bigger mass. You should shift this guy towards the fulcrum. And when you shift it at a distance towards the fulcrum, the system will be what? Balanced. So, by shifting it, if initially the distance was 3, it will change to, it will be less than 3. And if it is less than 3, it makes sense because what we have been doing since. I hope this makes sense. So, the actual answer is option B. When you move P nearer to O, when you move this guy nearer to O, the system will be in equilibrium. I hope this makes a lot of sense, okay? But you don't have any business with moving Q to O, no. You don't have any business with that. Because if you move Q to O, Q is one of smaller mass. So it must have more distance to the pivot than this P of bigger mass. I hope you grab, okay? So that's basically all on this aspect, basic moments problem. Now let's look at moment of a couple very quickly. Then we'll just trash reactions and incline problems, okay? So if you are enjoying this video, do also like, subscribe, and if you want to learn more about Ajaks tutorials, Ajaks tutorial is an online tutorial centered at providing quality lectures online. This is actually our YouTube channel, but we have paid classes that we organize. So if you're interested, my number is on the screen. Text me on WhatsApp to be a part, okay? Now let's go. Moment of a couple. All right, so now let's look at moment of a couple. Moments of a couple. Now, moment of a couple is very, very simple. All right, it's very, very simple. But the thing you need to know is, it's very, very simple in exam. What you just need to know is, what is a couple? Write this down. A couple is a system of equal but opposite forces acting on the same line of action. Is that clear? Now, this is how a couple is. Some questions will use rectangle, something like this. So my F and my F. Or some of them can use a circle, do something like this. My F, down here again, my F. Just like your tap. That's what a couple is. Okay? So, anyone is fine. Now, there is usually a distance. There is usually a distance. Distance X. Distance X. And the distance is always perpendicular, or it must be perpendicular to what? The forces. So, now, a moment is a system of two equal but opposite forces. That means this force is equal. They are equal, but they are opposite. One is going up, one is going down. Do you understand? Now, how can you find the moment of a couple? The moment of a couple is defined or is gotten, or moment of a couple equal to force, one of the force multiplied by the perpendicular distance along its line of action. Okay? Now, let me give you an example. If you have let's say 3 Newton, 4 meters, and you're asked to find the couple, the moment of the couple, the answer is 12. 3 times 4. That's it. So, moment is basically, that's 12 Newton meters, right? So, the moment of the couple is basically you taking one of the force and multiplying it by the line of, by the perpendicular, listen, perpendicular distance along its line of action. That's all. If you have another one again, 12 Newton, let's say the distance now is 1 meters. What's the moment of the couple? Moment equal to what? 12 times 1. 12 Newton meters. So that's basically what a couple is all about. That's all. No extra question. Now, there's something that I want to show you. There's a very popular JAMB question, and the question is like this. And the question says, what is the moment of this couple? Or what's the moment of this particular body? Now, the moment of this body here is 5 multiplied by 0, which is 0 Newton meters. Why is it 0 Newton meters, class? It's 0 Newton meters because moment is force multiplied by the perpendicular distance. What's perpendicular? At right angle. This is perpendicular. So, this is straight. There is no perpendicular here. So, there is no perpendicular distance. That's why it's 0. But this one, force, perpendicular, force, perpendicular, force, perpendicular, force, perpendicular, force, perpendicular. That's it. I hope this makes sense. This is what we call it on moment of a couple. That's all. No extra thing. Just go to your past question and solve. Force, perpendicular. You're done. Just pray you see this a lot in your exam because it's simple. Okay? Now let's look at the last part. Reactions and incline moment problems. So this one is very, very critical because JAMB brings it out a lot because they know that many students don't really know it. Okay? It's simple. I will teach you to the best way that you are going to learn, and there is no question you will not be able to solve. Okay? Let's start. Reactions and incline moment problem. So welcome back. Now let's look at the reactions and incline problem. So reaction and incline problem. We're going to continue from where we stopped. Question 13. You see it on your screen now. The diagram below shows 3 forces which keep the bar AB in horizontal equilibrium. Which of the following is correct? So this is my diagram. This is my diagram here. F1. sorry, F3, F2 is my A, my B, and there's one here, F3, F1, F1. So they said, which of the following is correct? Now, this is very, very simple. Note this thing down. Note. Write it in your book now. The sum of upward forces is equal to the sum of downward forces. Note this thing now. Like now. Write it down now. The sum of upward forces is equal to the sum of what, class? Downward forces. Is that clear? Good. So, how many upward forces are here? F3 and F2. So, F3 plus F2 is equal to F1. Option D. That's F1 equal to F2 plus F3. Option D is correct. I hope this makes a lot of sense. Good. Question 14. Now, question 14 says, in the diagram below, you see it now on the screen now. In the diagram below, what is, let me show this is recording. Okay, in the diagram below, what is the value of W? What's the value of W? Now, this is the diagram here. You can start trying it too. I'll put the question on your screen. You can start trying it now. O W X 1 meters away, G 1 meters away, then up we are having a tension which is 20 meters, then 1 meters away too. Now, this is it here. That way, the real diagram is on your screen. Okay? Now, listen attentively. Let me tell you something. Listen. Note that weight is a downward force. Tension and reactions are upward forces. Okay? Good. Now, this is the pivot. This is the diagram. They say, what's the value of W? How can we find the value of W? Now, you remember I told you that upward force is equal to downward force, right? But that doesn't mean you will now say W is 20 because the tension is 20. No. You cannot conclude that because you need to first find, you can't conclude that because there is a distance, there's a perpendicular distance to the pivot. So you must find the moment up equal moment down. Do you get? Now let's find the moment about this pivot. Moment about this pivot. Okay? Let me show there's no other thing we're missing out on. Nothing. Good. So moment about the pivot, T multiplied by 1 equal to, are you following? W multiplied by what? 1 plus 1. Do you get the perpendicular distance? Perpendicular distance. So we already know that my T is 20. So let's just move this to 20. So W will now be equal to, this is 2W equal to 20. So what's my W class? 10 Newton. You can see how simple it is. Very simple. Option A, correct. Now question 15. This is question 14. Okay. Question 15 says, this is very, very good. I'll clean here. I'll draw this thing here and I'll clean here and do it. A uniform beam HK of length 10 meters. No, let me just clean the board. Now let's look at question 15. It says a uniform beam HK of length 10 meters. So it means from here to here is 10, right? So let me just put the meters down. So this is 0 to 10. So 10 meters. And weighing 200 newtons. So the weight of this guy is 200. So if it's 10 meters in weight, then it means that the weight, if it's 10 meters in length, then it means the weights are at the middle, right? So let's see somewhere here. My weight. And this is at what? 50 centimeters. 50 meters. I mean, sorry, 5. Yeah, 5 meters. Okay. So the weight is 200. Weight is 200 Newton. Is supported. Now, support means a pivot. It means a knife edge. It means a fulcrum. That's support. So it is supported at both ends. So it is supported here and it's supported here. Okay? As shown in the figure, a man weighing 1000 newtons stands on P. So it starts on point P. So at this point is a weight here that is 1000 Newton. So it stands at point P on the beam. If the reactions at H and K are respectively 800 Newton and 400 Newton, what is distance HP? Now, reaction is an upward force. So it means there's one reaction here and there's another reaction here. I think my light is blocking it too. But just know that this place, they said H and K. So at K, here is 400. I hope you can see this is 400. Okay, it's 400. And here is what? 400 Newton. And here is what? 800 Newton. Reaction is an upward force. That's basically it. Reactions and inclined moment problems. So what's distance HP? So what's from here to here? Now, how can we solve it? Very, very simple. Very, very simple. First of all, they have given us a reaction here, and I've given us a reaction here. Now, if you do your mathematics, look. 800 plus 400 is what? 1, 2. 200 plus 1000 is what? 1, 2. You can see that law of equilibrium applies. That upward force is equal to downward force. Okay? Now, let's find X. That's not really our business. Let's find X. How can we find X? You can take moments about, I want to do something. I'll take moment about pivot P, pivot H. I'll take moment about this support H. And you take moment about support K. Let's solve together and tell me what you got in the comment section. Try it. It's very simple. Just follow the same steps I'm taking. Now let's take moment about pivot H. Or support H rather. So, taking moment about this guy, it means that if you are taking moment, listen attentively, open your ears. If I'm taking moment about this support, it means this 800 will not have any effect. Why will it not have any effect? Because there is no perpendicular distance to this thing. There is no perpendicular distance here. The support is on the pivot. Do you understand? So since the support is on the pivot, it means there is no perpendicular distance, so there's no moment. Are you following? So the only the only reactions we are going to use is this one, 400. Do you get? Now, let's solve. So taking moments about support H. Now, when we want to take moment about support H, what is it going to be? Follow me. 400. Just do up moment equal down moment, right? 400. What's the distance covered by the 400? Remember that the total length of this rod is 10. So let me show this is recording. So the total length is 10. So this 400 is taking, like, the perpendicular distance between this 400 Newton to this support H is what? 10. You know what? I'll solve the two of them so that you guys will not get confused. So you can master it. So this equal to, now we have done for the up, now let's do for the down. So how many forces do we have down? 1000 and 200. Let's start with which one? Let's start with 200. So 200 multiply by, what's the distance from 200 to this support? 5. Remember, this is 5. So from here to here is 5. Do you get? Plus 1000 multiplied by, what's the distance from 1000 to this one is X. That's what we're looking for, HP. You can see how I've done this now. I can find my X from there. Okay? This is what? 4000 equal to, this is what? 2 times 5 is 10. right? So this is 1002 plus 1000x. Do you understand? 4000 minus 1000 is what? 3000. Equal to what? 1000x, I mean. So what's my x class? 3000 over what? 1000. That's what? 3 meters. So this is my what? HP. Distance HP. And from the option A is correct. Do you understand? Now, how to take moment about support K, and let's see. Taking moment about support K. Now, if I'm taking moment about support K, open your ears clearly. I will get the same answer, but there is not the same methodology. I mean, the same methodology, but we're not going to be seeing the same values. Let's solve. Now, I'm taking moment about support K. Just like I said here, if I'm taking moment about this place, it means this 400 Newton will have no perpendicular distance. So the only reaction I'm going to consider when taking moment about support K is 800 Newton reaction. Do you understand? So 800 Newton multiplied by what's distance from this 800 to this support K? 10. Equal to, now we are done with the upward force, right? Now let's look at downward force. So downward. So from here, remember this is what we're looking at. This is where you're taking moment from. So from here, you're taking moment. So 200, this is 5, and this is 10. 10 minus 5 is 5. So 200 times 5 plus, now listen. What's the last force here? 1000. So what's the perpendicular distance between 1000 to K? Support K. 1000 is at X, right? But from year to year, this whole thing is 10. So if year to year is X, then year to year is 10 minus X. So that's my perpendicular distance, right? So that's 1000 multiplied by 10 minus what? X. So this is going to be what? 8000 equal to 1000 plus 1000 times 10 minus X. Leave like that. I don't want to have the big numbers. Are you following me? So 8000 minus 1000 is 7000 equal to 1000 bracket 10 minus X. Class, 7000 divided by 1000 is what? 7. So 7 equal to 10 minus X. So this is going to give me X equal to what? When X is coming here, 7 is coming here. So 10 minus 7. That's what? 3 meters. HP. The same. You can see. So you can use anyone. So I hope this makes sense. This is a JAMB question. These people are crazy. But it's simple if you are in other tutorials. So that's basically it. You just choose any support and you take moment about the support and you get the same answer. Sometimes, listen attentively. Sometimes they might not give you this one. So I think they told you a support, a reaction R was acting on K. Now, how can you find that R? You can find that R by saying upward force equal downward force. 1000 plus 2000, which is 12, minus 800, which is 400. Do you get? That's how you can actually find that one. But you cannot do that kind of method when you are having unknown here and unknown here. Do you understand? Don't worry, we'll solve more questions. Let's look at more questions on this. Okay? Question 16. You see it on your screen now. The diagram above, a lever of length 200 meters is used to lift a load of mass 180 kilogram. The pivot at P is 20 meters from the load. What is the minimum force that must be applied at the end of the lever? Now, you see that diagram? Let me explain it here properly. This is how the diagram looks like. There is a force which is 800. It's not 800 they said. Let me go back. 180 kilogram. Are you following me? Then there is a pivot, and that force is, this whole thing is 200 meters, so 0 to 200, and this force is 20 meters to the pivot. So this is 20, this is 200 meters. Are you following? Then I said, what will be the force that must be applied at the other end of the lever? So this is one end, this is another end. So we're looking for the force here. And your options are in what? Newton, right? So this guy, let's change this thing to Newton. This is mass, 180. So 180 multiplied by 10 is 1800, right? Newton. I hope this makes sense now. We're mature enough to understand what I just did. So we're looking for the force. That's all. Nothing again. So what are you doing? You are saying 1800 multiplied by 20 equal to the force multiplied by what? 200 minus 20. Minus 20. So this is what? 1800 multiplied by 20 equal to, I hope you are following me. This is what? 180F. My F is the minimum force, so my minimum force F will be equal to 180 into 1800 is what? 10. 10 times 2 is what? 200 Newton. That's all. Option D. I hope this makes sense. Good. Now let's look at question 17. And you see question 17 on your screen now. What is the moment of the force F about point P in the diagram shown below? So now you're asking for the moment. Now this is the diagram here. There's a force down. There is an angle P, and there is a distance Y, like this. So this is the diagram, and there's an angle here theta. Now pay attention. Let me tell you something. You know, okay, don't worry. Let's continue. Let's solve this question. They said, what is basically the moment of this force? Now, what's force, class? Moment is force times perpendicular distance. I told you. And perpendicular distance means that there's a force here. See, force, the perpendicular distance will be here. Now, let's bring this thing here. I want to do something. Just follow me. The distance Y, theta, F. Ideally, let me get another marker. Ideally, it is meant to be force, this force, multiplied by a distance here, because it's perpendicular. Do you understand? Or this force multiplied by a distance here, the same thing. So let's use this. Now, this particular distance here is what we're looking for, which is my, now, okay, calm down. Follow me. This part is Y, right? This part is Y. And if this to this is theta, it means that this to this is what? 90 minus theta. Are you following? Do you agree? So it basically tells us that my force in this whole thing is going to be, if this is 90 minus theta, if this place is Y. Okay, calm down. This place is Y, right? And this theta here is 90 minus theta, right? Now, do you know that if this place is Y, then it means this place is Y cos theta, and this place is Y sin theta. Note that horizontal component is cos theta. Vertical component is sin theta. Do you get it? Do you understand? So it means that my moment in this particular question is meant to be my force multiplied by a distance here. And that distance here is y cos theta. Do you understand? So f multiplied by y cos theta. Now, for my option, for my question, many of you pick option A. Option A is wrong. Let me tell you why. Now, I just told you that this is y cos theta, this is y sin theta. That doesn't mean in this question in particular it is y cos and y sin. Let me explain. Listen. The angle here in this context is 90 minus theta. So this place is y cos 90 minus theta. And here is y sin 90 minus theta. But why I told you it is cos here and it is sin here is because so you don't get confused. If you are already known that horizontal is cos, vertical is sin, I don't want to confuse you. But this is it. Y cos 90 minus theta. Why is it 90 minus theta? Because this is what we're looking for. This part here. We need the angle here. Do you understand? I can actually prove this using stroke as well, but no need. Okay? Just know y cos 90 minus theta, y sin 90 minus theta. Now, this theta is changed to what? 90 minus theta. So this is what? My moment is equal to what? F y cos 90 minus theta. Now, if you look at your options, there is nothing like that. But recall when we started this video on that special angles, I told you that cos 90 minus theta is same thing as saying what? Sin 90 minus theta. I mean, it's same thing as saying sin 90. Sin theta. Sorry, what's wrong with me? I'm already tired. So this moment equal to Fy sin theta. That's the answer. I hope this makes a lot of sense. So that's basically it. Fy sin theta is correct. And that's option B. Now let's look at question 18. Question 18 says, this is very, very sweet. It says the diagram below shows a uniform wood of weight 200 Newton and length 50 meters. It is pivoted at one end and suspended by a cord at the other end at angle 30 to the wood. Calculate the tension of the cord. Blah, 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 blah. Now, look, question 18. Let me draw the diagram. This diagram here is a pivot. Listen attentively. There's a pivot at an angle 30 degrees. 200 is here. Now, let's interpret what the question says. Let's go back. And this thing here is a tension. Now, let's go back to what the question says. Said the diagram below, diagram on the board, shows a uniform wood of 200 Newton and length 50. So, it means from here to here, remember this is a dot, dot, this is dot, 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 dot. This is not part of the length. So, the length is 50 meters. So 0 to 50. Okay? It is pivoted at one end. That's at the extreme end here. And suspended at the other end. You can see, so this is an end. Suspended. You drag it with a cord. You drag it. So when you are dragging with a cord, what's happening there? There's a tension upward force. Okay? Now, calculate the tension in the cord if the wood is horizontal. So we're looking for T here. Now listen attentively. When you want to solve moment question and you are given an angle, what you do is you resolve this to horizontal vertical component. Do you understand? And how can you resolve this to vertical component? T sine 30 degrees. As long as the angle is to the what? Horizontal. That was why that initial question that I gave you before, that was like this, that theta was here. That's why I said 90 minus theta, because this is what we need. We need the angle to the horizontal. If it's not to the horizontal, then this thing, we can't say that the force here is F cos theta. Cos theta is wrong. It's meant to be cos 90 minus theta. Do you understand? So all angles must be to the horizontal. As long as it's to the horizontal, then the rule that says vertical for sine, horizontal for cos applies. Do you understand? So any question you are given on moment, always take it toward vertical. All right, because we need it. We need it as an upward force. If it's horizontal, there is not going to be any perpendicular distance. So we need it to be vertical so that we can take a perpendicular distance to the pivot. Do you understand? Now let's resolve this. A tension upward T sine 30 degrees at 50 meters, a pivot 0, 200 Newton. Where did they say this 200 Newton is situated? Okay, it is the weight. It is the weight. So it means that it is at 25. It is the weight. It means that it's at 25. So let's put it at 25. So it is the weight of the rod. So 200 Newton. So it's at 25 centimeters mark. 25 meters mark rather. I hope this makes sense. So I'm looking for T. Abi? Okay. Simple. So what do we do, class? This perpendicular distance equal to this perpendicular distance. That's all. So we have T sine 30 multiplied by what? 50. Do you get? Equal to 200 multiplied by what? 25. Oh, Jesus. T sine 30 multiplied by what? Multiplied by 50 equal to 225. Do you get 50 here 2, 50 here, that's 25 here 1, 25 here 2, right? So we have 2t sine 30 degrees equal to 200. 200 here 1, 200 here 100. That's so t sine 30 degrees equal to 100. Now sine 30 is what? 1 over 2. So t multiplied by 1 over 2 equal to what? 100. So what is my t finally? My t will be equal to what? 2 times 100. That's what? 200. So my tension is what? 200 Newton. I hope this makes a lot of sense. Question 19. Hey! If you don't understand this video, my God will judge you. Okay? Now, question 19. A uniform light beam XY is hinged. Hinged is a form of a support. When you get to university, we're going to do different kinds of support. We have fixed support, we have hinge support, we have roller support. So each is a form of support. Okay? So a uniform light beam XZ is hinged at X. So the diagram is there, number 19. The diagram is there. So this is Z. This is F force. This is Y. There is something here. 0, 30 degrees, a tension, and this thing is 200 centimeters. This thing is 300 centimeters. All right. Okay, so let's continue the question. Now the question says a uniform beam XZ is hinged at X and kept in equilibrium by forces tension and F as shown on the diagram. If XO is 200 and OY is 300, express T in terms of F. Now, when the question says express T in terms of F, it means find T, but F should be inside. Okay. Now, let's solve. I will need to clean this place, but let's solve first. Follow me. Now, we are taking moments about the hinged. You know, I told you hinge the kind of support. See, it's why you need to be in other tutorials, because imagine you don't even know what hinge is now. You'll be confused. So moments, this hinge is a support. So you put it here. So let's take a moment about the hinge support. So I told you that this guy always resolve first. So remember, when resolving this will be what? Tension sine 30. Do you get? So up that's T sine 30 multiply by what? 200. The distance now, right? 200 equal to this force here, downward force F, multiply by, now listen attentively, this is 300 plus 200, that's 500. Do you get? 0 cancel 0, so I'm having T sine 30 degrees multiply by 2 equal to 5F. Do you understand? Very simple question like this. Very simple question like this. This body is dirty, I'll clean it. Okay, so what are we going to have? T sine 30 equal to 5F. Class, what's sine 30? 1 over 2, right? So T 1 over 2 equal to 5F, right? Hope I'm not making any mistake. Hold on. This. Hope I'm not making any mistake. Hold on, no. Number 19. This multiplied by this. Wait, did they tell us anything like? Okay, I'm not making any mistake now. So what am I T finally? Hey, I shall know. I know the answer was 5F. So this is T multiplied by this. We forgot our 2 here. So 2 cancel 2. So what is my T? 5F. Correct. Option D. So I hope this makes sense. Very, very simple. Now let's solve our last question. Question 20. Let me rub this off. It's dirty. Let's take the last question. Question 20. Now question 20 says a rod PR is balanced on a pivot. So rod PR, P and R is balanced on a pivot at NR. So this is where the pivot is, at NR. While a string is used to support the rod at P. So since a string, there will be an upward tension, right? So a string supporting it. So there's a tension here. The weight of the rod 9 Newton acts at point Q. So it's going to be in the middle. And this is point Q. So this is the weight of the rod. The torus is 9 Newton. So put 9. Put 9 Newton. Are you following? Good. Act at point Q, where QR is 30 centimeters. So the distance here is 30. And PQ is 15 centimeters. What's the tension in the string? That's all. So, taking a moment about this pivot. About the pivot. What is it going to be? Tension multiplied by what? 15 plus 30, which is what? 45. Equal to 9 multiplied by what? 30. So this is what? T equal to 9 times 30 divided by what, class? 45. Are you getting it? 9 here 1, 9 here what? 5. 5 here 1, 5 here 6. Oh, 6 Newton, sorry. 6 Newton. Option B. So I believe we all understand everything we have done, and we started with moment definition, principles, special angles, basic moment problems, moment of a couple, reaction, and incline problem. Now what I want to implore you to do is go to your past questions, solve as many questions as possible. If you have any questions at all, drop in the comment section. I'm going to drop the assignment immediately I'm done with this video. I'll put it on the screen now. You can see it, right? Please attempt the assignment and ensure to like, subscribe, share anything you want to do the video. Please make sure you share with your friends. Okay, I remain Ajaks, your Ajaks tutorials, and like I said before, if you are interested in joining our tutorials, my number is on the screen. We organize tutorials for JAMB, WAEC, post-UTME, NECO, GC. So it depends on when you're watching this video. We are organizing paid classes on WhatsApp and Telegram. Okay, so text them on the screen to be a part. Have a lovely day. Bye.
Ajaks Tutorials is more than just an online tutorial. It's a community built on innovation, hard work, and excellence. Ajaks Tutorials has consistently set the pace for academic success, tripling her records every year and guiding countless students into their dream institutions. In 2024, Ajaks Tutorials produced 75 students with 300 plus, with the top students emerging 9th nationwide. In 2025, the number soared to 238 students with 300 plus, with the top students ranking 8th in Nigeria. And in 2026, Ajaks Tutorials is set to do even more. Through well-structured online classes, expert tutoring and personalized support, Ajaks Tutorials is redefining quality education. Ajaks Tutorials is headed by Ajakaye Joseph Oluwaseun, the CEO, founder, and a passionate educator and educational consultant, along with this powerful team of seasoned tutors. To be part of the next success story, contact us via the number displayed. Join Ajaks Tutorials today.